Hello everybody, I'm Suman Matthews and today we'll be discussing a topic, Introduction to Functions. This is a part of grade 11 maths and NATA maths. So this channel has videos for grades 11, 12, engineering maths and the GRE quantitative section. Consider subscribing to my channel or you can visit my page. So what do we learn about in this video? We learn about sets, relations and how functions are derived from them. Very often we wonder about what are the types of the functions. So here we discuss one-to-one, onto, into and many-to-one functions. And have you heard about the modulus, signum and greatest integer functions? We discussed that also as a bonus. So we first introduce set theory. If A and B are two sets, the Cartesian product of A and B is defined as the set of all elements A cross B, which is a set of all elements xy where x belongs to A and y belongs to B. So the x coordinate belongs to A, y coordinate belongs to B. So if P is 7, 8 and Q is 4, 5, 2, what is P cross Q? We take the x coordinate of P and group it with all elements of Q. So we have 7, 4, 7, 5, 7, 2. Then what do? We take the x coordinate of 8 that again group it with each element of Q. 8, 4, 8, 5, 8, 2. So if A has m elements, B has n elements, A cross B has mn elements, m into n. So number of elements in A cross B is number of elements in A into number of elements in B. Now what are relations? If A and B are any two non-empty sets, then any subset of A cross B is called a relation from A to B. So a relation is basically a subset of A cross B. And domain of the relation is the x coordinate and range of the relation is the set of all elements y such that y belongs to B, xy belongs to R. Coming to questions, R is the set of all elements xy where xy belongs to integers y equal to 2x minus 4, a minus 2, 4b squared belong to R. We need to find a and b. So what happens if a minus 2 belongs to R? It satisfies this relation. So I have minus 2 is 4a minus 4. Again 4b squared belongs to R. So what happens to 4b squared? It satisfies this relation. So b squared is 2 into 4, 8 minus 4. So a is 1 and b is plus or minus 2. Now, this is a formula for how do you find the number of relations from A to B. So if A has m elements, B has n elements, number of relations from A to B is 2 raised to mn. Coming to question 2, if A has elements 2, 3, 4, 5, 6, R is the set of all elements xy such that y equal to x plus 1, where xy belongs to A, list the elements of R. So what happens here? The y coordinate is plus 1, the x coordinate. So I take 2, 3, 3, 4, 4, 5, 5, 6. Can I take 6, 7? No. Why? Because 7 does not belong to A. So this is your relation. Coming to question 3, determine the domain and range of the following relation. R is the set of all elements xy such that x belongs to natural number, y belongs to natural number, x plus y equal to 10. So how do we start? We take all the natural numbers such that the sum is 10. So how many elements do we have? We start with 1, 1, 9, 2, 8, 3, 7, 4, 5, 5, 5, 6, 4. Can I do 7, 5? No. 7, 4, no, because 7, 4, the sum is not 10. Then 7, 3, 8, 2, 9, 1. So your domain, what is your domain? All the x coordinates, 1, 2, 3 up to 9. And what is the range? Again, all the y coordinates, we arrange it in ascending order. So we have 1, 2, 3 up to 9. So a function is a special kind of relation. A function is a subset of A cross B such that every element of A is assigned to a unique element in B. So what happens here? F is a function from x to y. We write f colon and x. We write an arrow y. This means f is a function from x to y. Here a is assigned to 1, b is mapped to 1. So 1 is the image of a and b. And what are a and b? The pre-images of 1. Similarly, what is 2? The image of c. And what is c? The pre-image of 2. Coming to question 4. If A consists of elements 1, 2, 3, 4, B consists of elements 1, 5, 9, 11, 15, 16, F consists of the set of all elements 1, 5, 2, 9, 3, 1, 4, 5, 2, 11, are the following true? F is a function from A to B, F is a relation from A to B. So is F a relation from A to B? Yes, because the x coordinates are 1, 2, 3, 4 which belong to A, and the y coordinates are 5, 9, 1, 11 which belong to B. So what is a property for a relation? It is a subset of A cross B. So F is a relation from A to B. But what about a function? What property have we given for a function? Every element of A is assigned to a unique element in B. Here 2 is assigned to two images, 9 and 11. So it is not a function. Now we come to the type of functions. If f is a function from x to y, f is called one-to-one or injective if distinct elements in x have distinct images in y. What are many-to-one functions? As the word suggests, f is a function from x to y. For many-to-one, two or more elements in x have the same image in y. Again, f is called onto or surjective if every element in y has a preimage in x. So D and D has preimage A, E has preimages B and C. And what is an into function? F is said to be into if, this stands for exists, there exists at least one element in y which does not have a preimage in x. So here 1 has preimages A, B, C. Does 2 have a preimage? No. So 2 does not have a preimage. So this is an into function. Coming to problems, list the relation. Is the relation a function? If so, what type is it? So here -1 is mapped to 1, 0 is mapped to 0, 1 is mapped to 1, 2 and -2 are mapped to 4. So I write it as -1, 1, 0, 0, 1, 1, 2, 4, -2, 4. It is a many-to-one function because -1 and 1 are mapped to the same element, 2 and -2 are mapped to the same element, and it is onto. Why is it onto? Because every element in the codomain has a preimage. Now coming to the types of functions, we first define the greatest integer function, bracket x, which is defined as the greatest integer less than or equal to x. We define bracket x. How do we define bracket x? -2 when x lies between -2 and -1. Between -1 to 0, what is the greatest integer less than or equal to x? -1. Between 0 to 1, what is the greatest integer less than or equal to x? 0. Between 1 and 2, the greatest integer is 1. So it will come like this. It is closed at these points, -2, -1, 0, 1, and open at these points because -2 to -1, we don't include -1. So the open bracket, open circle here. So because it is like a step, we call it what do we call it? The step function. Next we come to the modulus function. The modulus function is defined as x if x greater than 0, 0 if x equal to 0, equal to -x if x less than 0. So when x greater than 0, it will be like this. When x less than 0, it will be like this. So this is the graph of the modulus function. What is this? The modulus function graph. Next we come to the signum function. Signum function is defined as fx equal to mod x by x when x not equal to 0, equal to 0 when x equal to 0. And from the modulus function, when x is greater than 0, mod x is x, and x by x is 1. So fx is 1 if x greater than 0. When x less than 0, mod x is -1. So it's -1 if x less than 0, equal to 0 if x equal to 0. So the graph will be something like this. 1 if x greater than 0, -1 if x less than 0. So what are the three functions we have learned? Modulus, signum, and the greatest integer functions. They are all very important functions in calculus. So we have learned about sets, relations, functions, types of functions, and learned a few problems on them, and also learned these three functions. So do consider subscribing to my channel or visit my page. I would love to hear your feedback, and thank you.